Troubleshooting variable speed motors, like troubleshooting anything, requires information about how the device works and the proper tools for the job. To help with that, in 2004, we introduced a pamphlet called the Home Comfort Guide. The Home Comfort Guide covered variable speed motors only and how to troubleshoot them. In 2006, we updated that guide to include the new X13 motor. It still covered variable speed, but also covered X13. And this year, in 2009, we introduced the new next generation ECM service guide that also includes the Evergreen and the outdoor fan motor. So currently on our website at thedealertoolbox.com, you can download or purchase this guide, and it will help you walk through everything I'm going to cover here today. So, one thing I want to talk about before we actually troubleshoot the motor itself is other issues you can have, primarily having to do with airflow. Many of us think that because this is a variable speed, constant airflow motor, that I should just never have any airflow problems. And that's just not the case. The variable speed, constant airflow motor is speed limited, so it can only run so fast before we are going to limit the operation of the motor to protect the motor. That means if your ductwork is too small, your filters are too dirty, your registers are closed, or even if you don't have the right airflow selected from the dip switches or jumper pins on the boards, you might not have the right airflow. So what I'm getting at is there's going to be times where you're going to be diagnosing a variable speed system where the motor's running, but you're not necessarily getting the airflow you need. In that case, I would go after the dip switch and jumper pin settings using the OEM manual, and I would check all of my airflow concerns on my system. So now let's talk about troubleshooting a motor that's not working. And that actually is very easy because there's only 4 things that can really be wrong with a variable speed motor that's not operating. Keeping in mind that this is an electronic device, and this electronic device needs 2 inputs to run. It needs the communication input to tell it when to turn on, and it needs the high voltage input to give it the power to operate everything inside the motor. The other 2 potential things that could be wrong with the motor are a bad control or a bad motor itself. So again, the 4 things: no communication to tell it when to turn on, no power to run, a bad control, or a bad motor. So in my opinion, that's kind of a good thing. We're no longer troubleshooting run windings and start windings and capacitors. It's literally just, is the electronic device getting the 2 inputs that it needs to run? So let's start with the high voltage input. All of our variable speed motors since the first generation 1.0, which we haven't made for about 15 years, use a 5-pin connector. And I almost made a mistake there. Before we would disconnect any of our plugs, we would want to turn the power off on our HVAC system. So I've turned the power off, and I'm going to now disconnect my plug, and then I'm going to turn the power back on my HVAC system so I can check the voltage on this plug. And the voltage on this plug is going to be the same as what's driving the HVAC system, either 120 or 240. And you can use any clamp-on, digital, or even analog voltmeter. We're just going to use a simple digital voltmeter here. And I'm going to put my connections on the black and the white wire, which in the case of a 120 volt system, I would see 120 volts between my black and my white wire. In the case of a 240 volt system, I would see 240 volts between my black and my white wire. And then I would also want to check between the black and the ground to make sure that I have a good ground as well. So we've already diagnosed that we have power to our 5-pin connector. Let's just assume that we didn't have power there and we repaired that. That may be the only problem and we're ready to put it back on the motor. We would then of course turn the power off and plug it back in. Okay? Now let's assume that we already had power there and we think that there may be other problems. So we're going to turn our power off and we're going to disconnect our communication connector. Now the only difficulty in troubleshooting the communication to variable speed motors is that over the years we've used AC communication, DC communication, and in the case of the new 3.0, serial communication. Unless you had the OEM manual for the specific appliance that you're working on, you wouldn't know which type of communication was used or where that communication should be on any of the pins. For that reason, we've developed a tool called the TechMate, specifically the TechMate Pro. With the TechMate Pro, with the flip of one switch, you can get a go, no-go operation out of the motor. So we're not actually going to be checking the voltage or the communication coming to the motor. We're simply going to give the motor a good known communication and make sure that it works. So to use the TechMate, we obviously have to disconnect the communication connector. And it's worth noting that the communication connector's latch is on the inside, whereas the high voltage plug latch, or latches, I should say, are on the outside. So when they're connected in the motor, it's very difficult to only disconnect the communication connector. It's much easier, of course, after you've turned the power off, to disconnect the high voltage plug and get it out of the way, and then disconnect your communication connector. The TechMate is the ultimate all-in-one tool when it comes to troubleshooting variable speed motors. The current generation TechMate is the TechMate Pro with a single switch on it. Some of you may have our previous generation, the TechMate XL, with 4 switches on it. Both of these devices will troubleshoot our models 2.0, 2.3, and 3.0 motors. The only thing that's needed for either device to troubleshoot the 3.0 motor is the 16 to 4 pin adapter, which if you buy a TechMate Pro today, the 16 to 4 pin adapter comes with the device. If you currently have a TechMate XL, you can order these as well as the TechMate Pro on our website, thedealertoolbox.com. With the TechMate Pro, obviously we've simplified the product a little bit. There's just one switch. And there are instructions on the back. They tell you to turn on the switch. With the TechMate XL, you do need to follow the directions on the back. They will tell you which switches to turn on to get the proper operation out of the variable speed motor. So, on our TechMate, we have 2 connections. We have a 16-pin connector that we will plug into the motor, and we have 2 wires. These 2 wires are what will power the TechMate, and we will connect this to 24 volts. And that can be 24 volts at your thermostat connections or 24 volts directly at the transformer. And I should also say that even though they're 2 different colors, they are not polarity sensitive. You can connect them to either side, common or 24 volt. When the TechMate is connected properly, you will also see a green light on the switch. If that light is not there, either one of our alligator clips has fallen off or we have a bad TechMate. In either case, we cannot troubleshoot until we make sure we have the green light on the motor. I should also pause right here and say that if you are working on one of our next generation 3.0 motors, you can still use the current generation TechMate that you can either purchase now or you may already have by using our 16 to 4 pin adapter. So you would take the 16 pin on the TechMate, plug it into obviously the 16 pin end, and plug the 4 pin end into the next generation 3.0 motor. So your current TechMate, if you already have one, can troubleshoot our next generation serial communicating product. All right, so let's put the TechMate back into the motor. Now this is a running test, so we do have to have power on the motor. So of course we've got the power off. We're going to plug our 5-pin connector back in, which we've already confirmed we have power on. We double check to make sure we're plugged in on our TechMate and we have a green light. And the next step is really difficult. We flip the switch. And that's really all there is to it. We should get a go, no-go operation out of the motor from this very simple test. Now, obviously, if the motor does not run, there's something wrong with the motor. But let's look at another scenario first. Let's say the motor does run with the TechMate. That means that with our tool sending a known communication signal to the motor operates. But with the OEM wiring harness, the motor does not operate. So that means the problem is not with the motor, it's back in the HVAC system. And you know, I was in the field for about 10, 15 years, and I remember what it was like to want to say, oh, it's just the board. Well, it's not always just the board. We have to remember that the thermostat demand has to be coming down to the board to tell it when to turn on. Our low voltage wiring needs to be connected correctly. We could have tripped safety switches. Is the sequence of operation at a time frame where the motor should turn on? Is the 16-pin connector in good shape? There's a lot of very small pins in this harness, and we would want to check them from the motor all the way back to the board. If all of those things are good, yes, we could have a problem with the circuit board in the HVAC system. And in that case, we would need to use the OEM manuals that come with the system to troubleshoot the communication on that board. And I should also mention that some manufacturers make tools like the TechMate for troubleshooting this communication on their systems. So let's look at the other scenario. The other scenario is I flip the switch on the TechMate and the motor does not run. In this case, I have proved that the control, the microprocessor end of the motor, is no good. However, what I don't know is the motor any good, because with variable speed motors you can replace the control separately from the motor. So before we can remove the control and check the motor, we have to turn the power off and wait 5 minutes. So we'll do that now. When we come back, we'll go ahead and diagnose the motor.